All right, our next presentation, he's not here, but we're going to. He's online. Dr. Folmer?
Want to say something, Michael?
Michael?
Hello, can you hear me?
Okay, just hang on just a second. Okay. Okay, Michael, I'm going to introduce you.
Okay.
Okay, so Dr. Folmer's online. He's going to talk to us about evaluations conducted at the National Hurricane Center, the Weather Prediction Center, the Ocean Prediction Center, and the Satellite Application Branch. You gave me that list. Dr. Folmer has over 10 years of meteorological experience and currently works as a satellite liaison for the NOAA, National Weather Service, for the Geostationary Operational Environmental Satellite R-Series, or GOES-R. Also, the JPS's Proving Ground at the National Weather Service Ocean Prediction Center, as I already said, and the Information Satellite Analysis Branch. So he's going to give us a talk. Hang on just a second, and let me get your presentation up, okay?
Okay.
Okay, Michael, if you could just say next slide, since you can't, it's not interacting with you online. So we're at the.
Okay. Sounds good. So thank you, everyone, for especially Christy and Gary for accommodating as I do this from the Mid-Atlantic version of the Arctic tundra today. As you can see, I'm going to be talking about the JPSS evaluations at what we call our satellite proving ground, the Marine Precipitation Satellite Analysis, for all those acronyms that Christy just tried to describe. So if you go to the next slide, this just gives you an idea of the NOAA NWS Marine Responsibility Area. So for JPSS, one of the main focuses for our proving ground has been for the Ocean Prediction Center and the Satellite Analysis Branch. And then to some lesser degrees, the Weather Prediction Center, although they're finding more and more uses, and then the Hurricane Center for tropical. And if you hit enter, it should zoom in. I don't know if you've already done that, but zooming in, the point was to show you that the Pacific side of our areas of responsibility has been our main focus up to this point. So if you go to the next slide, I'm going to talk about some of our current polar satellite uses at these centers. Next slide. So here is one of the slides I really want to hone in on is trying to make polar orbiting imagery easier access for the forecasters. All right, so NASA Sport worked with us on developing a MODIS, VIIRS, and AVHRR display so that we can get multiple polar orbiters in one field of view. As you can see here with Alaska, this is used a lot for the ice as well as for any storms that are going to be moving either from the pole or into the Bering Sea. So the forecasters are finding this type of a display much more useful for our operations. So we're getting to use the imagery much more. Next slide. So this slide is layered precipitable water analysis. This is the product that has been produced by STIRA with John Forsyth and Stan Kidder through the years. And the Tropical Analysis and Forecast Branch has been finding this useful for tracking the moisture surges associated with African easterly waves, or tropical waves. So you can see the total precipitable water on the upper left, and then compare that with the surface to 850 millibar layered precipitable water. This is the analysis that they have found very useful. So it's a new way of using the data that may not have originally have been thought of, and they've been thrilled to have it, and I don't think they can live without it now. So a nice accomplishment there. Next slide. I pulled this example as one of our more recent uses in November of 2017 for a West Coast heavy rain event. And forecaster David Roth from the Weather Prediction Center made mention of using the surface to 850 layered precipitable water as a way of showcasing where the highest areas of moisture would be located for the atmospheric river. And if you go to the next slide, you'll see I put together a short animation here showing you the moisture plume coming up to the east side of Hawaii. And actually, it's a rather robust area of moisture that was surging into the California, Oregon coastline. So again, this particular product has been one of our main emphases as we have been conducting our evaluations. The next slide shows you one other product. This is the explosive cyclogenesis of our most recent storm from January 4th. And the ozone anomalies and tropopause level products that have been produced by Emily Byrne and Brad Zavosky at NASA Sport are products that are getting much more visibility, and we hope to tie that into some of the special projects that I'm gonna show you shortly. So if you go to the next slide, this is just the introduction of our proving ground activities for special projects. So next slide. So one of the first things I want to hit on is some of the work that's happening at the Hurricane Center. CIRA has a hurricane intensity and structure algorithm that they've been working on. And the idea here, as you can see, the purpose is to provide satellite-based tropical cyclone intensity estimates on a global scale, objective and independent of the Dvorak technique. And they are making it operational on multiple satellites and instruments and making it available to the center. So the next slide shows you some of the operational satellites that are currently in use. So all the NOAA birds, MEDOP, and SNPP, and they are getting ready to upgrade to JPSS-1 or NOAA 20 now, and we'll eventually add Tropics and MEDOP-C in the near future. So the next slide shows you one of the example products coming out of this. It's the maximum sustained wind estimate for Typhoon Noru from this past year. And all the individual dots represent estimates from the various instruments. And then the red line is your intensity estimate alongside. So I want to thank Galina Chirkova for giving us a sampling of this particular technique that we hope to make it into operations for this next hurricane season. Next slide. The VIIRS high-resolution infrared has been used more and more because of the nadir view compared to when you have tropical cyclones that might be getting near limbs in particular of the geostationaries. So here is again Typhoon Noru and a 12Z on the, I'm sorry, I said that wrong. On July 21st, the 1527Z, you have 35 knots, and at this point, because of the displacement of the center from the deeper convection, this is more representing a steady state low-end tropical storm. On the next slide, on July 22nd, not quite 24 hours later, you have an increase to 45 knots and expected 40 knot increase over 36 hours rapid intensification due to the fact that the convection has now become more co-located with your center of circulation. So again, these nadir views really help with the center fixes. The next slide is the VIIRS day-night band center fixing. So this example, although the Hurricane Center doesn't have responsibility in the South Indian Ocean, you can see the tropical low-level swirl left over from a tropical depression near Madagascar, near the southwest coast of Madagascar. And as you can see in the infrared from the same VIIRS instrument, it's a little hard to see the low-level center. So I know we've seen examples like this in the past, but it's something we're putting more into practice at the Hurricane Center moving forward. Next slide. The final product that CIRA has been working on with us is the proxy visible imagery using the VIIRS day-night band radiances to train the product. In the past, the Hurricane Center was one of the only centers to have a visible to nighttime shortwave IR with a smooth transition along the terminator on the geostationaries. So they're actually training the product using VIIRS day-night band radiances. And if we go to the next slide, you'll see an animation of this. And most of that animation there is actually in the shortwave band. And then you can see the terminator move across when you go to the visible during the daytime. So we're pretty excited to get access to this over the next month or so to get us prepared for next season. All right, I see I'm about halfway through, and I think I'm doing okay here. So next slide is just to introduce one of our special projects that we're doing at the Proving Ground, which is an explosive cyclogenesis project. And as you can see, a lot of my co-authors right there. So next slide. One of the questions we've been trying to answer for the Ocean Prediction Center is how can we integrate all these great new satellite products and techniques to help with some of the forecast challenges we face on a daily basis. So stratospheric air intrusions seems like a logical concept with the amount of explosive cyclones that we see in the Ocean Prediction Center waters. So this project right now is focused on the water vapors, the 3 from Himawari and GOES 16, as well as the air mass RGB product, both from the satellites I just mentioned, as well as from MODIS, and looking into trying to get the VIRS CRIS version back up and running. We have the OSI new caps, total column ozone anomalies. One thing that's not mentioned here is we will be using new cap soundings as well moving forward. And then, of course, our ASCAP, which OpenSea could not live without, as well as the AMSR wind data. So if you go to the next slide, this is just an example of one of these events. Our student cleverly named it Winter Underdog from January 18th of 2017, or 2016 rather. And with the comma head and then that area of dry air through our water vapor contributions, those are the areas we're focusing on. So if you go to the next slide, you will see a comparison of air's air's ozone anomaly on the left, which we don't have airs anymore, and then new caps on the right, which is what we've just started introducing. And some of those anomalies, although there isn't a legend, and I apologize for that, are approximately 125 to 150% of normal. So these would be considered significant based on the climatologies and much of the research done beforehand. If you go to the next slide, this just gives you an idea of that same storm. At peak intensity, we have ASCAP B on the left, and then the AMSR winds on the right. And although the AMSR winds can be rain contaminated, in the areas we're looking at, it's usually rain-free. So the hurricane force winds are actually verified for this particular storm, thanks to getting these timely passes. Next slide, we have a March 31st storm. In the North Atlantic, on the left you see the air mass product again, and the 2 areas that are circled actually wound up merging and becoming a much larger, stronger system. And the ozone anomaly from new caps on the right shows the anomaly being approximately 125 to 130% of normal at that time. And this was significant because it moved much of the ice that was broken up from the ice sheet in the Davis Straits and along the Labrador and Newfoundland coastlines into shipping traffic. So if we go to the next slide, this became a rather high impact. This is a true image on the bottom from the Canadian press of such a series of icebergs that got in the way of shipping traffic. And the one bullet point, although it's the smallest type on the page, or one of the smaller types, the icebergs, for the first time in many decades, reached the latitude where the Titanic sunk. And this is a pretty significant issue. So we're actually using our research on explosive cyclogenesis to now work with the National Ice Center, the North Atlantic Ice Service, and we're even going to be talking with Alaska about this in the coming weeks, about how we might be able to combine the 2 projects into a larger scale project. So if you go to the next slide, here are 3 time series, stamps, if you will, after major storms from the North American Ice Service. As you can see, the icebergs at one point reach quite a few degrees south of 45 north. And that happens to be in the heart of much of the shipping lanes for the North Atlantic. So we kind of stumbled upon this in the past year, and it's now become a higher priority for our Proving Ground focus. Then the next slide shows the two hurricane force storms that were in particular responsible for these systems, as you can see through our ASCAP passes here. You actually on the left-hand side can see the hurricane force winds, while on the right-hand side, the hurricane force winds are most likely in the swath that is not covered by the passes. And so we are looking at ways that we can fill in those gaps with the knowledge of the stratospheric intrusions. So if you go to the next slide, I'm on my final special project. This is extratropical transition of tropical cyclones that I've been working on with Emily Byrne for a few years now. Next slide. So our poster child storm, although some would think it was Sandy, Sandy kind of started everything, but Hurricane Arthur wound up being a rather unique system, especially for our friends up north. Nova Scotia wound up having significant damage as the system transitioned from a hurricane to an extratropical hybrid. And as you can see here in the water vapor image, the implied region of Stingjet is right where those gradients come together, actually, so that oval is just a little bit offset. But Halifax did record an 87-mile-per-hour wind gust as the storm went by, and much of the low-level circulation did not exist anymore at this timestamp. So we're trying to find ways to help forecast these transitions and the after effects. So if you go to the next slide, on the left you have the MODIS air mass RGB, and on the right you have the co-located AIRS ozone anomaly. As you can see, although there's no way for me to draw on here, that area of red coming through Pennsylvania, West Virginia, Ohio, is co-located nicely with those ozone anomalies that you see in the blue on the right-hand side. If we go to the next image, or the next slide, you'll see that we were able to get our hands on some aircraft data while they were sampling the storm with the P3, and then the NewCAPS profile that was closest at that time. And as you can see, that same area of dry is pretty well represented in NewCAPS, so we actually think we have something we can work with moving forward here, especially in the absence of any aircraft data. Next slide. So during the extratropical transition phase of Arthur, we sampled a few different NewCAPS profiles through this, and as you can see, there's varying levels of dry air, but in particular, if you look at profile 16, which is north of Nova Scotia, kind of in that area between Newfoundland and other parts of eastern Canada, you can actually see, although the air mass product depicts a more moist and somewhat warm air mass, much of that is above the level at which the dry air is gliding underneath. So we will look more into these gradients and how they help with not necessarily the transport of high momentum wind, but also in the way that it might affect the low-level boundaries and therefore low-level jets that could then mix down these high wind gusts. The next slide is just to show you, this is from MERA reanalysis from NASA, and just depicts what the tropopause undulation, tropopause fold looks like in this particular case. You can see the stratospheric air actually, and the high PB air actually gliding into the lower levels, descending into the lower levels is what I'm trying to say. And finally, the last slide here for this project, on the left you have total calm ozone, and on the right you have the ozone anomaly. And as you can see, these high levels of ozone actually are rotating around what is now the extratropical form or post-tropical form of Arthur. And as you can see, for the time of year, for July, these are well above normal at approximately 150%. So again, this is a project that's continuing to unfold. We have many storms to add to it, along with our explosive cyclogenesis, so I will be pretty busy for a while. So the next slide is just a quick plug for the Satellite Liaison blog. I especially want to thank Bill Line, who was a liaison at one point, and to some extent still is, working at the Pueblo Weather Service, National Weather Service Forecast Office. He's really kept the blog alive lately, and we hope to really increase exposure moving forward. And finally, my last slide is just my question slide, but I thought everyone would get a kind of an kind of sense from this gorgeous high-resolution visible image from VIIRS of our most recent explosive site. And with that, I am done and hopefully on time.
You're perfect. Thank you so much.
Michael, could you hang on the
No
line just a
problem.
little while in case you get any Slido questions that he needs to address?
Right.
I had a hard time hearing that. Could that be
So
repeated?
would you stay online for a few minutes and so we may have some questions on Slido for you.
Are there any
Okay, sure.
are there any questions for Michael? Slido currently has none for Michael. Michael Folmer. Oh, we have one that just showed up.
Okay. Do you want to?
Yeah, I'll read that one off. Yeah, just leave them up there. All right, to Michael Fulmer, has the OPC increased their interest in using polar capabilities in the Arctic region?
Absolutely. That's actually going to be expanding much more as the National Ice Center is now working much more closely, in fact, co-located to some extent with the Ocean Prediction Center. So from an ice standpoint, as well as from storms in the Arctic, we plan on using polar much more moving forward.
Okay, thank you.
Thank you, Jordan.
Thank you, Michael. Have a great day. I'm gonna hang up.
Okay, thank you.